Welcome back. Today we have day 12. Our goal for today, given a word problem, you will be able to set up a system of equations to represent it and then correctly solve. So today we're going to be working again with systems of equations. So this is our third day working with systems, but today everything is going to be in a word problem. Okay, so let's remember our word problem steps. Number one, you're going to put your pencil down and you're going to make sure you read the problem all the way through. Then you have to decide if there's one unknown or two unknown values that you're trying to solve for. You're going to define each variable, let x equals. You might say another one could be let y equals, or you could say let a equals. So you can use any variables you want, but remember, if you want two variables, you need two let statements. Okay, then you're going to write out your equations. If you have one variable, you're going to have one equation. If you have two variables, you're going to have two equations. Okay, and then step number 5, solve each equation or system of equations. And remember, systems, that's what we've been working with the last couple days. You can solve using substitution or elimination. So substitution, or elimination. Okay, so let's go ahead and let's follow through these steps in our first question. All right, so pencils down, let's go ahead and read. A baseball manager bought 4 bats, 3 baseballs for $76.50. On another day, he bought 3 bats and 1 dozen balls at the same rate and paid $81. How much did he pay for each bat and each baseball? Okay, so now let's make a decision. How many variables are we trying to solve for? Or how many things are we trying to solve for? What's the main idea here? How much did he pay for each bat and each baseball? So there's 2 things we're solving for. So if we're solving for 2 things, we need to have 2 let statements. So I'm going to come over here now and say, let x equal the cost of a bat, and let y equals the cost of a baseball. Okay, so now that we know we're going to solve for 2 things, that also means we're going to have 2 equations. So let's go back now and reread the question to see if we can find our important information. A baseball manager bought 4 bats, 9 baseballs for $76.50. Now they're saying the relationship between these items is that they all go together. 4 bats, 9 baseballs, $76.50. Then we have on another day he bought 3 bats, 1 dozen balls at the same rate and paid $81. So these are all going to go together. So let's see if we could transfer the words into an equation. 4 bats, the cost of a bat is x. So 4x, the word and means plus, 9 baseballs, so that's 9y. The word for is like the word is, it means equals $76.50. Now let's take a look and see if we can come up with our second equation. 3 bats, so the cost of each bat is x. 1 dozen balls, remember 1 dozen is actually 12, so that's 12y. Okay, and they paid $81. All right, so now we have our 2 equations. So now that everything is set up, all we have to do now is solve using substitution or elimination, which we've been practicing over the last 2 days. Now, if I look carefully here, I notice my x's line up, my y's line up, my equals line up, and my constants line up. So I'm going to go ahead and use the elimination method. So I'm going to multiply everything in the top equation by 3. And I'm going to multiply everything in the bottom equation by -4, because that way my x's will cancel when I add them together. So when we do this, remember, when you multiply, you have to multiply everything, which includes the cost. So if I take a look here, we're going to get 12x plus 27y equals $229.50. Now, when I multiply through here, -4 times 3 is -12x. -4 times 12 is going to give us a -48y. is equal to negative 4 times 81 is going to give us a negative $324. Okay, so now that I have manipulated the equations, it's very easy to see that we're eliminating the 12x's, which then if we add everything else together, we're going to get negative 21y is equal to negative $94.50. So then I divide both sides by negative 21, and we have y equals $4.50. So the cost of each baseball is $4.50. Now that we have y, we still have to find x. So I'm going to take my y and I'm going to substitute it in. I'm going to use the first equation. So we're going to have, so that's a 4x plus 9. And now I'm going to substitute in the cost that I just found my y for, equals $76.50. Now if I multiply those together, we get $40.50. And everything else remains the same. Okay, I subtract $40.50. So then we get 4x is equal to 36. Divide by 4, and we have x is equal to $9. Okay, so now we've just solved for our x and our y. So if I come back over here, I know the cost of each bat. Okay, I'm going to put this back in my let statements is $9. Make sure that we actually solved for both. And the cost of each baseball we found was going to be $4.50. So there we have our final answers. Okay, so now that we did one, let's go down and let's try another one. So one day, Mr. Bucka paid $18.70 for 4 kilograms of walnuts, 3 kilograms of pecans. On another day, Mr. Bucka paid $13.30 for 3 kilograms of walnuts and 2 kilograms of pecans. If the rate of price per kilogram were the same on each day, find the price per kilogram of each type of nut. Okay, so the first thing we have to do is ask ourselves, what's the main idea here? How many things are we solving for? Are we solving for 1 or are we solving for 2? Well, here it says each type of nut. So there's actually 2 types of nut here. There's walnuts and pecans. So that means we're going to have 2 let statements. I'm going to write let W equal the cost of walnuts. And I'm going to say let P equal the cost of pecans. Now we can reread to find our important information. So 1870, 4 kilograms of walnuts, 3 kilograms of pecans. And then we have 1330 for 3 kilograms of walnuts and 2 kilograms of pecans. So we're going to go ahead now and let's take these sentences and let's change them into equations. So 4 kilograms of walnuts, 4W, and plus 3 kilograms of pecans, 3P. Okay, and the total cost was $18.70. And down here we have 3 kilograms of walnuts and 2 kilograms of pecans, and that price was $13.30. So once again, it's set up very nicely for elimination. So go ahead, I'm going to have you pause the video and solve this one on your own. All right, let's see how you did. So I multiplied the first equation by 3, the second by -4. All right, here's the work that I did, and I was able to get a grand total of $2.90 for the pecans and $2.50 for the walnuts. All right, let's go ahead and flip the page and try another question. So let's take a look now at number 3. Tickets for a dance cost $10 each if purchased in advance, but $15 each if bought at the door. If 100 tickets were sold and a total of $1,200 was collected, how many tickets were sold in advance and at the door? Okay, so let's ask ourselves, what are we trying to solve for? What's the main idea here? Well, we want to find out how many tickets were sold in advance and at the door. So there's actually not just one type of ticket here, there's 2 types of tickets. So we're going to need 2 let statements. So I'm going to say let A equal the number of tickets in advance. So they bought their tickets ahead of time. And I'm going to say let D equal the number of tickets at the door. Okay, so now we have our two let statements. So now we have to read and find our important information. So tickets for a dance cost 10 each if purchased in advance, and 15 each if bought at the door. We have 100 tickets were sold, so there's a total of 100 tickets, and we have a total of $1,200. Okay, when you get a question like this, I'm going to tell you this one phrase that I want you to remember. Money, money, money. Money, money, money! Put all the monies together. Okay, that's always going to be your first equation. When it's written like this and you have money, money, and money, well, the monies are all going to go together. Okay, so let's go ahead and let's write that out. So 10 in advance, so $10 is going to go with A. Okay, so 10A plus $15 for tickets at the door, so that's going to be $15 is going to go with our D. And the total money that was collected was $1,200. So money, money, money. The monies go together. Okay, so now we still need to come up with another equation. I already used the $10, I already used the $15, and I already used the $1,200. So what's the only other piece of information that we haven't used yet? Well, that's the fact that there were 100 tickets sold. So does that mean there were 100 A tickets? There were 100 D tickets? Or were there 100 of both of these combined? Well, it doesn't tell us exactly, so that means it has to be both of these combined. So that means when you both of these combined, it's going to be the A tickets plus the D tickets equal the total tickets, which is 100. So A plus D equals 100. So the number of tickets in advance plus the number of tickets at the door equals a total of 100. So now that we've set it up, we're going to go ahead and solve. Now if I take a look here, I notice my A's line up, my D's line up, my equals line up, and my money lines up, or my constants line up. So I'm going to solve this using elimination. I'm going to keep the first equation the same, and I'm going to take the second equation and I'm going to multiply everything by -10, and that's going to eliminate my A's. Okay, so let's go ahead and I'm going to have you pause the video and I'm going to have you solve this using elimination. All right, let's see how we did. So when we solved using elimination, we were able to eliminate the A's. We got D is 40. I plugged it into the second equation, got A equals 60. So tickets at the door were 40, advance tickets were 60. Okay, let's try another one now. Let's take a look at number 5. So we're going to skip number 4. So let's take a look here. Molly spent $1.80 on candy. Bubblegum was 15 cents, Tootsie Rolls were 10 cents each, and the number of Tootsie Roll purchased was 2 less than the number of pieces of gum. How many pieces of each type of candy did Molly purchase? Okay, so stamps, this is just going to be candy. All right, so let's take a look here. How many let statements are we going to need? Well, we have bubblegum and Tootsie Roll Pops. So let's go ahead, pause the video, write your 2 let statements. Okay, so now that we have our 2 let statements, I used X and Y, we have to come up with our equation. So I'm going to remember money, money, money. All the monies are going to go together. So let's take a look. We have $1.80 total. Bubblegum is 15 cents each. So remember, cents has to have a point. So 0.15x plus 10 cents, that's 0.10 for the Tootsie Rolls, which is Y, equals $1.80. So money, money, money. Now for our second equation, we have to read really carefully here. The number of Tootsie Rolls purchased was 2 less than the number of pieces of gum. So they don't give us a total here, but they're saying Tootsie Rolls purchased. So Tootsie Rolls, that's your Y, equals, so that's the word was, means equals, 2 less than the number of pieces of gum. So 2 less means we have to subtract 2. All right, so here we have now our 2 equations. Go ahead, solve this on your own. All right, so I solved using substitution, and by doing that, I was able to get x equals 8.